السلام عليكم. Our lesson today, inshallah, is an introduction in complex number. What is the meaning of imaginary number I? For example, find in R the solution set of the following: x bar 2 plus 1 equals 0, x power 2 equal -1, then x equal square root of -1. And square root of -1 doesn't belong to real number. Then solution set is phi. Here I can say I power 2 equal -1, where I equal square root of -1. Again, if the solution set equals phi in R, I can say I power 2 equal -1, where I is imaginary number, where I equal root -1. Then x power 2 equal I power 2. I will take square root, then x equal positive or negative I. Then the solution set here is I and -I, but in a real number is phi. Remark, I doesn't belong to R. R, the real number, consists of rational and irrational. And I doesn't belong to R. If the second one, if A and B belongs to R negative, then square root A times square root B doesn't equal square root of AB. If again A and B belongs to R negative, then root A times root B doesn't equal square root of A product B, because here A and B are negative. For example, find the set of imaginary number that the solution set of the following. First one, 25, x bar 2 plus 16 equal 12. 25 x bar 2 equal, I will subtract 12 minus 16 equal -4. Then x bar 2 equal -4 over 25. Then x equal positive or negative square root of -4 over 25. I say here -4 is -1 times 4, and -1 x equal positive or -4 over 25, and replace -1 by I power 2, and I will take the square root. Then x equal positive or negative. The square root of 4 equals 2, square root of 25 is 5, and the square root of I power 2 equals R. Again, 25 x power 2 equal -4, then x power 2 equal -4 over 25. I will take the square root to both sides, then x equal positive or negative square root of -4 over 25. Here I can replace -1 by I power 2. And I will take the square root of 4 over 25 as 2 over 5, and the square root of I power 2 equals I. Then the solution set is 2 over 5 I and -2 over 5 I. I is imaginary number, where I is equals the square root of -1. Integer power of I. If I is root -1 and I power 2 -1, I power 3 equals I power 2 times I, then I power 2 equal -1 times I equals -I. I power 4 equals 1. Again, I equals the square root of -1. I power 2 equals the -1. I power 3 negative I power 4 equals 1, and so on. I can keep it. I power 4n equals 1. Here, this is a rule. I power 4n equals 1. Letter B, I power 4n plus 1 equal, I can expand this form, I power 4n times I. Here, I can expand the power, I power 4n times I equals I. I power 4n equals 1 times I equal I. The third one, I power 4n plus 2, I can expand power 4n plus 2 by I power 4n times I power 2. I power 4n equals 1 and I power 2 equals negative 1. 1 times negative 1 equals negative 1. Letter D, I power 4n plus 3 equals, I will expand this power I power 4n times I power 3. I power 4n equals 1 and I power 3 equal negative I. Then 1 times negative I equal negative I. Example 3, simplify each of the following I power 19. Here I power 19 equals I power 3. Again, I power 19. Here, what is the number can divisible by 4? I power 19 divisible by 4? No, I will take the previous number. I power 18 can divisible by 4? No, I power 17. I power 16. Here, I power 16 divisible by 4 and the remainder is 3. Then it will be I power 16 times I power 3. I power 16 equals 1 and I power 3 equal negative I. Here, I power 42. 42 can divisible by 4 or not? 42 can't divisible by 4. I will take 41 can't divisible by 4. 40 divisible by 4 and the remainder is 2. Then I can write I power 42 as I power 40 times I power 2. I power 40 equals 1 and I power 2 equals negative 1. Then 1 times negative 1 equals negative 1. I power 101. 101 can divisible by 4. I will take 100. 100, yes, can divisible by 4. Then I can expand this power as I power 100 times I power 1. I power 100 equals 1 and times I equals I. I power 4n plus 23. I can expand it also. Equals I power 4n times I power 23. I power 4n equals 1. And I times I power 23. 23 can divisible by 4. I will take 22, 21, 20. And the remainder, it will be I power 3. I power 3 equals negative I. I power negative 19. I will take number more than 19 and divisible by 4. I will take I power negative 20. I power negative 20. I power 20. I power 20 equals 1. Why? Because 20 is divisible by 4. Then I power negative 19 times I power 20 equals, I will subtract the power. In the case of multiplying, negative 19 plus 20 equals I power 1. Again, if the power is negative, I will multiply this imaginary number by another 1. This number is equals 1. Here, I will take number more than 19. More than 19 and divisible by 4 is 20. Because I power 20 equals 1. Why? Because 20 can divisible by 4. Then, in the case of multiply, I will add the power. Negative 19 plus 20 equals 1. Then it will be all. Here, the set of complex number. What is the meaning of complex number? It is the number in the form A plus BI, where A and B belongs to R and I is imaginary number. Again, the complex number is consists of real parts and imaginary parts. Here, A and B belongs to R. Find the solution set in the set of the complex number x power 2 minus 6x plus 13 equals 0. I will use here general formula. X power 2 minus 6x plus 13 equals 0. A is the coefficient of x power 2 equals 1. B, coefficient of x equals negative 6. And C is the absolute term. General formula equals x equal negative b positive or negative square root of b power 2 minus 4ac over 2a. By substitution, here x equal 6 plus or minus square root of negative 6 all power 2 minus 4ac, 4 times 1 times 13 over 2a equal 2 times 1. Then x, it will be 2 roots. X positive or negative square root of negative 16 over 2. Square root of negative 16, I can write it as negative 1 times 16. 16 is square root of 16 equals 4. And the square root of negative 1 equals I. Then 6 plus or minus square root of negative 16 over 2 equal 6 plus or minus 4i over 2. I can simplify it. 6 over 2 equal 3, 4 over 2 equal 2. Then the solution set equals 3 plus 2i and 3 minus 2i. Here remark, if z is a complex number equal a plus bi, where a is a real part and bi is imaginary part, then if b equal 0, then z equal a belongs to r is a real number. Again, if the b equals 0, then the complex number is a and a belongs to r. Letter B, if a equals 0, the real part equals 0, then z equal bi and z is imaginary number. Again, the complex number may be real also or imaginary also. Real if b equals 0 and equal imaginary number if the real part equals 0. Here, two complex numbers are equal. If and only if the two real parts are equal and the two imaginary parts are equal. For example, here, find the value of x and y which satisfies the following: 4x minus y plus 2x plus y I equal 5 plus 7i. Here the two numbers are equal. Two complex number is equal. Then the real part in the first equal the real part in the second, and the imaginary part in first equal imaginary part of second. The real part here is 4x minus y, and the real part here is 5. Then 4x minus y equal 5, the first equation. And the imaginary part here 2x plus y, and in the second number is 7. Then 2x plus y equals 7. I will solve the two equations by omitting and adding the two equations. 4x plus 2x equals 6x. Negative y plus y is 0. 5 plus 7 equals 12. Then 6x equals 12. Then x equals 2. Here, I will substitute by 2 in one of the two equations, first or second. They are the same. By substitution in the second, y, it will be 7 minus 4 equals 3. Then the value of x equal 2 and the value of y equals 3. Again, here I have two equal complex numbers. Then the real part of the first equals the real part of the second, and the imaginary part of the first number equals the imaginary part of the second. I will solve the two equations and find the value of x and y. Operations on the complex number. to add or subtract two complex number, we add or subtract real part together and add or subtract imaginary part together. And if I wanted to multiply the complex number, we do as algebraic expression. For example, find the result of the following in the simplest form. Here I need to add two complex numbers, 3 plus 7i plus the second one, 5 minus 9i. I will add the real part together. 3 plus 5 equals 8, and the two imaginary part, 7 plus negative 9i, it will be negative 2i. Again, I will add the two real parts together and the two imaginary parts together. 3 plus 5 equals 8. 7i minus 9i equals negative 2i. Then the result, it will be 8 minus 2i. Complex number also consists of real and imaginary parts. Here, if I wanted to subtract 2 minus 4i from 5 minus I, here I will subtract the real part together. 2 minus 5 equal negative 3, and I will subtract the imaginary part together. Negative 4, negative I, it will be negative 4i plus I equals negative 3i. Then the result, it will be 2 minus 5, negative 3, and negative 4 plus 1i equals negative 3i. How to multiply two complex numbers? Here, I will multiply 4 times 2 and multiply also 4 times negative 5i by algebraic expression, and multiply 3i times 2 and multiply also 3i times negative 5i. The first, 2 times 4 equals 8. 4 times negative 5i equal negative 20i plus 6i minus 15i power 2. Again, 4 times 2, 8. 4 times negative 5 equal negative 20i. 3 times 2, 3 times 2i equals 6i. 3i times negative 5i equal negative 15i power 2. Here, I will simplify it. 8 is a real. Negative 20i, 6i is imaginary number. I will add it. Add them. Negative 20i plus 6, it will be negative 14i. Here, negative 15i power 2. I power 2 equals 1. Then negative 15 times negative 1 equal 15. Then the result, it will be 8. I will add the two imaginary parts equal negative 14i. Here, negative 15i power 2 equals 15. I will add real also. 5 plus 8, 15 plus 8 equal 23, and negative 4i. Then the result, it will be complex, consists of real and imaginary. Here, if I want to multiply 5 minus 2i times 5 plus 2i, I will multiply also 5 times 5. 5 times 20i, negative 2i times 5, negative 2i times 2i. It will be 5 times 5, 25. 5 times 2i equal 10i. Negative 2i times 5, negative 10i. Here I have 10i minus 10i. It will be 0. And multiply negative 2i plus 2i. It will be negative 4i power 2. Here is the product of the difference between two expressions and the sum of them. It will be the square of the first minus the square of the second. Again, in grade 8, we talked before. If I wanted to multiply the sum of two expressions and the product sum and the subtraction between them, or the difference between them, it will be the square of the first minus the square of the second. Then 5 power 2 equal 25 minus 2i square equals 4i power 2. Here, negative 4i power 2. I power 2 equals the negative 1. Negative 4 times negative 1 equals 4. Then 25 equal plus 4 equals 29. Then the product of the two imaginary two complex number equals real. Here, this rule say 5 minus 2i times 5 plus 2i equals the first square of the first plus the square of the coefficient of imaginary number. 25 plus 4 equals 29. Here, perfect square. 3 plus 2i all power 2. I will square the first, square the second, and multiply first by second by 2. Then 3 power 2 equals 9. And square the second term equals 4i power 2 and multiply first by second by 2. Then it will be 3 plus 2 plus 2 equals 12i. Here, 9 plus 12i plus 4i power 2. 4i power 2 equals negative 4. 9 minus 4 equal 5. Then it will be 5 plus 12i. If I have 1 minus I all power 4, I can write it as 1 minus I all power 2, all power 2. And find the result of 1 minus I all power 2 is a perfect square and square it at the end. Here, 1 minus I all power 2 equals square the first, square the second, and multiply first by second by 2. Here, I power 2 equal negative 1, then negative 1 plus 1 equals 0. Then the result, it will be negative 2i all power 2. It will be 4i power 2 equal negative 4. What is the meaning of two conjugate numbers? Two conjugate numbers mean a plus bi and a minus bi equal or called two conjugate numbers. Why? Because here the same real and the two parts of imaginary number have different signs. Then a plus bi and a minus bi are called conjugate numbers. For example, 3 plus 4i, its conjugate is 3 minus 4i. 3 plus 4i, the conjugate of it, 3 minus 4i. I will change the sign of imaginary part. Here, 2i minus 5, it's a conjugate. I will change the sign of the imaginary. 2i, it will be negative 2i, and the real part is the same. It will be negative 2i minus 5. 7i, it's a conjugate. I will change the sign of imaginary number. It will be negative 7i. 8 is its conjugate is 8. I can't change the real part. I will change the sign of imaginary part only to find the conjugate. Here, the sum of two conjugate number is always the real number, and the product also, it will be real number. Thank you.